The important points for starting up the Fully HPLC. Right, first we don't want air going into the column, so disconnect it. I've done it like that, just putting a bit of tissue there to catch any solvent that drips through. The binary gradient pump here, we've got to turn or open up is probably the better way to say it, the valve, so we can bleed the system of air. Do that first before turning it on, and then we turn the system on, all the 5 switches there, turn them on before turning on the software on the computer. That's just the way we do it. So just go and turn them all on. That should be 5 switches. And then just check all the lights. See if there's any warning lights or one of them's not connected to the power or whatever. Sure looks good to go. So I just let it all warm up first. Everything will turn on, warm up, and then go over to the computer and turn the software on. Sure looks pretty good. Should be dripping here. Yep, that's good. And the column's disconnected because there's plenty of air in the system I can see this time. See the air bubble. Right, then we come over here to the computer. Double click on that one there. I haven't actually had this running for a few weeks. She's a bit slow to get going. It'll say the PDF signature module has failed to load. Don't worry about that, just push OK. Oh, good. Back in action. Yeah. Admin. Admin. Okie dokie. There we go. Software has found the machines. And we're going to go to the binary pump. Go to the method. And change that to isocratic. We've got mobile phase A and B on 50, which is the way I want it. And we're going to change that to 1. Yeah, it's hard doing this while filming. 1 millimil. There we go. You can see that's changed now. And this is all preparing to do the washing and clearing the system of air. So right click. Oh, purge plunger. There it goes. It's been a while since I've done this. And 1 minute, that looks good. Now you see this is all open up. So it's getting rid of all the air through the system before connecting it up to the column. I'm going to do this about 3 times. And while that's going, I'm going to do the needle wash. There we go. And this should start pumping here, yep. Push the needle, that's all good. I'll do that about 3 times, show you one more time, because I'm going to do this about 3 times. And start her up again. And then eventually, there shouldn't be a lot of air to be seen. Give it a wee flick. See the bubbles. So do this about 3 times, and at the same time just look around for any leaks or any problems. Just open things up. Everything looks good. The degasser, you can usually see air or air bubbles or whatever. that may need to get rid of. Everything looks pretty good actually. So I ended up purging plunger 4 times and it all looks pretty clear. And then I'm going to connect the line up to the column first and then turn off the bypass vent valve in that order. So this first, connect, then turn that tap off. Now once the vent valve is turned off, the pressure is going to start building in the system. This is where we get to see if there's a leak. This particular instrument has a problem with leaking the ferrule here, which is hard to source, the right size ferrule by the way, often leaks in this area as the pressure builds up. This is one of the biggest faults of this machine. So as you can see there, the pressure's building up, and at the same time as it's building up, I just keep an eye, especially in this area here, to see if it starts leaking or it just blows the ferrule out, in which case I've got to stop the pump and disconnect it, because I don't want to get air inside the column which can potentially bugger the silica lining inside it. So I've zeroed the graph to bring it on screen. It's looking good so far because it's actually reading something, and that ferrule hasn't blown out yet, it's not leaking yet, but the pressure's still very low. So I'm going to change this. I'll show you here. Go to method, to binary gradient, and the pressure's going to build up, and if it blows out, that's where it's going to do it once the pressure builds up. At the same time, we can see the settings. Alright, so we want to change this to 1.5. The reason is because go any higher and the system can't handle the pressure. The software has a fault, so what I do is I pull up, say, I could probably do it there, 1,5, and then copy and paste, and then push OK. The reason is because for some reason it's not allowing me to put 1.5 there. I can put 2, I can put 1, but I can't put point anything. This is the solution I'm using to get around it. I haven't found a fix for the software yet. And then push OK, and see that's changed. Binary gradient now, and the pressure is coming up. When the pressure comes up, it's leaking, it's blowing it out. That's a serious problem. Then I've got to come over here, turn the pump off, and take a look at this and and I'll release that there as well. Start again. This is the fun and games with not being able to source the correct ferrule. So I played around with it. I changed the connectors and the ferrules end to end, because this one's always been very stable, and I've run out of new ferrules. It's holding so far. As you can see, I'm wearing gloves because I don't want the solvent on my skin, and it's running relatively stable, but it's only running at about 11 megapascals, which is very low pressure. It's got to get right up to about 30. So we'll see what happens. We might try a run, and if it holds, bloody good, otherwise bugger. So I'll just quickly go over the settings. This is for testing mitragynine. If you want to see the method, come down and click, it says instrument method there, click on there and double click. So there's the settings for the sampler, the pump. You can see a nice slope on there. If it looks like that, it's probably correct. And the column box, it's got the temperature, the column type, the detector, the wavelength, all the settings are there. Just keep it like that. Can't go wrong. So you want to make sure that the needle's going to go into the correct vial. So it says LB2. I always double check before I start a run to make sure that the vial is sitting on LB2. You can see it there, see? LB12. Always double check that. Everything's set to run. So for each sample that I test, I just change the information here. This one's Rudizar, and the date, usually chuck the date in here. It only actually needs to do the initial run to get a pretty accurate result. Otherwise, well, each run is 20 minutes. It doesn't really need to do the actual proper run, which is after the initial run, because that takes 40 minutes. If there's something wrong or it's not nice and stable, then maybe do 2 runs on the first one, and then the next vials just do the one 20-minute run, and it's going to be accurate, guarantee you, because I've tried many different things. It's very reliable. Yeah, it's all running nice and stable. It's a nice stable line, and to show the sequence, just to get rid of it, to increase the size of the graph, you just click on that one there. So what I'm going to do is I'm going to do a run, which click that one there, and then the pressure will increase and we'll see if it blows it out or not. It's just like a trial run. I've got an old sample in there in the vial, just an old vial there, should still read something, and we'll see what happens. So she's all ready to go, vial's in the correct place. Everything's good. It's all ready. It's all green. It's all up to that bloody ferrule there. Right, let's give it a shot. Yes. Right, so come over here. And LB2, I always have another little double check. The needle goes down into the vial, yep. Just had a big drink. Right, now, as you can see, the pressure is over time increasing. I'll get rid of that sequence by pushing that. And just watch the graph. It's nice and stable, that's what it should be doing. Nice and straight, everything's looking pretty good. Yeah, it's very normal for it to have a couple of peaks right in the beginning. Everything's normal so far. It should be detecting the mitragynine around 14. I increase this to 21, 21, because the run finishes in 20 minutes. Everything's good so far. Good. So it's running well. I've got it running at a slightly lower pressure. It's found the mitragynine peak there, which is a nice high peak by the looks of it. It's over 1.5. And it's not leaking. Fantastic. This is only actually the initial run. So I'll come over here, I'll bring up the sequence. You can see it's still doing the initial run. But before that finishes, because I've already found the peak, it's going to run for 20 minutes. I don't really need it to, because this is just a trial run anyway to see if the ferrule blows out. So before it finishes, I'll stop it. But usually you just do the complete run. Or stop it before the end of the run because you're confident that you've got the peak and everything's going to come together. Over here and stop it. Yes, we stop it. Then get rid of that. And go down here to compounds. Now we want mitra to be marked on the graph. So highlight, see, can you see? I just highlight on there, there'll be a cross, double click on that. And then the exact readings here, push save, save, and save here, yeah, save there, and that's it. If we scroll down, scroll down, it will say Mitra, which is number 50, and all the information's there, which is saved on the graph. So you can jump straight to the graph by, if you go to print report, there it is, and you can save it on the desktop and write a name for the file, save it. I'm not going to do that this time, but there it is, the area, so you can work out exactly how much mitragynine, and in this case it's a pretty good result. If you want to go back, go to there, click, and then you're back onto it. And to save solvent, you can turn off the pump. So green is off. So now it's not running lots of solvent through. So you can get ready for the next test, or whatever you need to do, or just leave it running and then change the vials, change the vial for the next test. So done a couple of tests, we're going to shut the machine down. Just click there, the corner, and it says Are you sure you want to quit? Yes. Select all. Okay. And we shut the software down before we turn the machine off. And then just have 5 switches. It's here somewhere. No, she's all shut down, turned off. Leave that tightened. Leave everything in place. And don't open anything up because air gets inside it. So the tap's shut, everything's closed. And then you can walk away and come back 2 months later and she's all good to go.